Hi, it's Dion Raskina, and today I'm going to go over FRQ 2009 number 6. This problem deals with the graph of f prime of x, and will be asking us to find points of inflection and our derivatives and absolute maximum. This problem is a calculator permitted problem, however they give us all the information we need to solve all three parts, so we don't actually use the calculator at all. Part A asks us to find all values of x at which there are points of inflection on the function f of x in the open interval from -4 to 4. We can use the graph of f prime of x given to solve this problem. Possible points of inflection are when the slope is 0 or undefined. The slopes are 0 at x equals -2 and x equals 3 times ln of 5/3. The slope does not exist at x equals 0 because there is a cusp. Therefore, the right-hand limit and the left-hand limit are not the same. F prime of x is decreasing from the interval -4 to -2, but at -2 it changes to increasing until x equals 0. But when x equals 0, the function f prime of x begins to decrease again until x equals 4. Since the function f prime of x changes from decreasing to increasing at x equals -2, and from increasing to decreasing at x equals 0, there are points of inflections at these places. Part B asks us to find f of -4 and f of 4. The problem gives us the original amount, f of 0 equals 5, and we will need to add this on to both f of -4 and f of 4. The problem also gives us that from -4 to 0, f prime equals g of x. G of x is a semicircle. From 0 to 4, f prime of x is 5 times e to the -x/3 minus 3. Let's start with f of -4. We can use the graph to solve this one. Like I said earlier, we must add 5, the original amount, to it, so f of -4 equals 5 plus the integral from 0 to -4 of g of x. The integral of g of x is the area bounded by the x-axis in the curve. In the video there is a purple area and orange area. We have to subtract the orange area from the purple area to get the integral from 0 to -4 g of x. The rectangle has an area of 8 because the length 4 times the height 2 equals 8. We can find the area of the semicircle with the formula pi r squared over 2. The radius is 2, so 2 squared times pi equals 4 pi over 2, which equals 2 pi. Therefore, f of -4 equals 5 minus, because the integral was a negative, parentheses, 8 minus 2 pi. That equals 2 pi minus 3. Now let's do f of 4. This one is much simpler. F of 4 equals 5, the original amount, plus the integral from 0 to 4, 5 times e to the -x/3 minus 3 dx. We can make u equal -x/3, so then when you take the derivative of, so du dx equals -1/3 dx, and then when you move 1/3 to the other side, it would be -3 du equals dx. Then you substitute that in, and you get 5 plus parentheses -15 e to the u, which you substitute in -x/3 minus 3x. And then from the integral of 0 to 4, f of 4 equals 18 minus 15 e to the negative 4 over 3. For the last part, C, we are asked to find an absolute maximum on the function f of x on the closed interval from negative 4 to 4. Once again, we can figure this out by looking at the graph. The absolute maximum of f of x is when the slope changes from positive to negative. The derivative function represents the slope, so the absolute maximum occurs at x equals 3 ln of 5 over 3, a number that we're given in the question itself. And because the function f prime of x crosses the axis and changes from positive to negative, that's how we know that that's where the maximum occurs.